Wim Quist is a Dutch architect that was born in Amsterdam on 27th of October in 1930. He designed buildings such as Rotterdam Schouwburg and Office Wilmswerf in 1980s. Another building of the same period is Maritime Museum in Rotterdam. The site. Maritime Museum is located in the center of Rotterdam, near Old Harbor. The building occupies the corner of two streets, Schiedamse Dijk and Blaak. It's 21 meters high and has column structure with a grid step of 10.2 meters. Sun path. In summer, the sun rises at about 6 a.m. and reaches the highest elevation angle of 60 degrees. The sunset in summer is about 10 p.m. In winter, sun rises at about 9 a.m. and the maximum elevation angle is 15 degrees. The problems. Chosen fragment is the atrium with glass roof and south-faced facade. Existing glass roof is the major problem of the chosen fragment. It has leakage and doesn't perform well enough. During summer, the atrium space of Maritime Museum overheats. In winter, heat is lost because glass roof acts as a cold bridge. Question and solution. The research question of our team is how to improve the energetic performance of the building, focusing on the use of natural resources in a more effective way. Natural resources available in current situation are wind, sun, and water. They could be applied on south facade or roof. Therefore, following solutions are presented. Solution 1. Double facade for ventilation. In terms of ventilation, the first approach is based on the principle of Debye's Tower in Berlin with double skin facade, which can be adjusted depending on occupants' wants. In summer, the main points of achieving comfort in their climate are to cool down the building and prevent overheating. As a result, the double facade will be an air curtain with up and bottom openings on external facade. However, in case of overheating, both of two facades can be open for immediate warm air exhausting. In winter, ultimate goals of double facade are to heat up the building and keep the warm air inside. In this case, both of two facades will be sealed. Then the cavity between two layers will generate greenhouse effect and perform as a buffer zone for insulation. Solution 2. Liquid facade. The key concept of the liquid facade solution merges two favorable results of the circulation of liquids within the transparent envelope. The system is based on the possibility to fill the cavity of a double glazing window with fluid like water, although the simplicity of the solution only prototypes have been produced. The most interesting results in the field have been achieved by McKee Ltd. During summer, the water in the liquid facade absorbs the energy of the solar radiations, reducing the transmission through the frame, minimizing the thermic gain of indoor spaces. The effectiveness is guaranteed by the production of flows in the cavities that replace continuously the heated water with new fresh water. A ventilated buffer between the two layers of the double skin facade helps to cool both of them, preventing overheating. Once the energy is absorbed, the water passes through an absorption heat pump where the heat is gathered to cool down a fluid for the cooling needs of the building. Especially in winter, the water continues to gather energy which can be used here to heat, switching the flow to a heat exchanger. Solution 3. Drum wall. The third solution for the chosen fragment is based on the concept of drum wall. that acts as a heat storage element. One of the examples is Halbau House in Princeton, United States. He uses strong wall with vents to improve energetic performance of the building. During summer, upper operable windows of outer glazing layer and upper vent dampers of inner layer are open, which allows rising hot air to come out. Ventilation doesn't allow any air heating inside the cavity, which prevents storm wall from overheating. Storm wall performs as an additional heat source during winter and mid-season time. During this period, upper and bottom vent dampers of inner layer are open. Cold air enters air cavity through bottom vents, heats up in the cavity, rises, and enters the room from the top vent.